All right, today we're going to do something pretty cool. We're going on a journey through billions of years of Earth's history. And you know what our guide is? It's the clues that ancient life left behind, right there in the rocks. We're going to piece them together to answer some really incredible questions. And we're starting with a real big one.
So to kick things off, let me just throw this out there. What if life itself, I'm talking tiny, microscopic life, was actually responsible for creating the very air we breathe? You know, the atmosphere that everything else, including us, would eventually need to survive.
Well, the answer is yes, a huge, resounding yes. It absolutely did. And you know, the proof for this massive planetary transformation, it isn't just some theory. No, it's a story that's written directly into the rocks, right into the fossil record.
So that brings us right to the first chapter of our story, the moment life started to reshape our entire world on a truly global scale.
Okay, so meet the heroes of this whole story, stromatolites. Now, these aren't just single organisms. Think of them more like layered structures, almost like living apartment buildings built by huge colonies of microbes. They showed up as far back as 3.5 times billion years ago, yeah, some of the very first life on Earth. And they had this totally revolutionary superpower, photosynthesis.
So how in the world did this happen? Well, it was basically a four-step process. First up, these stromatolites started pumping out oxygen, just as a waste product, right into the oceans. Now, for millions and millions of years, the oceans just soaked it all up. But eventually, they couldn't hold any more. They got saturated, and that oxygen had nowhere to go but up, escaping into the atmosphere. And that changed everything. It literally paved the way for a new kind of life that could actually breathe this brand new gas.
And here's the really crucial point. This wasn't just some small tweak. It was a co-evolution. See, life changed the ocean and the atmosphere. And then that new atmosphere turned around and allowed for a completely different kind of life to evolve. It was this incredible planet-wide feedback loop. And it was all started by tiny little microbes. Wild, right?
Okay, let's hit the fast-forward button by a few billion years. We're going to jump from that global microscopic scale to a very specific time, a specific place, and a really, really impressive creature that used to swim in the ancient seas.
Check this out. This is Eurypterus rimipace, but you can just call it the sea scorpion. It's way easier. It's actually New York State fossil. It's an arthropod that lived way back in the Silurian period. The easiest way to think of it is like a distant underwater cousin of today's scorpions and spiders.
And here's a fun little piece of science history for you. When paleontologists first dug these things up, they had no idea what they were looking at. Their first guess? They thought it was some kind of catfish. It just goes to show you, right? Science is all about discovery and, making corrections along the way.
But finding a fossil is really just the beginning. The real magic is figuring out its story. How did it live? When did it live? Who were its relatives? So how do scientists decode all that history from just a single piece of rock?
Right, that's the next big puzzle. I mean, you're looking at a fossil, a piece of rock, really. How can you possibly know how old it is? Or figure out if those little leg things were for walking or for swimming?
Well, the answer is this really powerful tool called a cladogram. The simplest way to think about it is like an evolutionary family tree. It's a map, really, that shows the relationships between different groups of organisms and pins them to a specific point in time, all based on the fossil record.
So, for example, by placing our sea scorpion on this cladogram, scientists can pinpoint its exact family, Eurypteridae. And from there, they can figure out that this family was around about 420 million years ago, and that its appendages, those were for swimming. All of those details just unlocked by organizing fossils into this big family tree. It's pretty amazing. But wait, the cladogram tells us even more than that. It can show us where these creatures lived and how that changed over millions of years. For instance, the fossil record shows that these eurypterids lived in deep marine environments for a huge stretch of time. We're talking about 100 million years. But then, way later, some of them actually adapted to live in freshwater, though for a much shorter time. It's a whole story of adaptation told just by looking at the rocks.
So, at the same time the sea scorpions were thriving in the water, another totally revolutionary change was happening. Life was getting ready to take its next giant leap out of the sea and onto the shore.
And what's so cool about this is that the next chapter of the story unfolds in pretty much the same place. Yeah, not far from where those ancient seas were, where Eurypterus was swimming around. A completely different kind of fossil tells the story of another world-changing event, and it's right there in Gilboa, New York.
These are the Gilboa fossils. And what you're looking at, found in rock from the Devonian period, are the fossilized stumps of ancient trees. And this wasn't just a couple of plants here and there. No, this was one of the planet's very first forests. A totally new kind of ecosystem was being born, right there on land.
And get this, these weren't little shrubby plants either. Based on all the fossil evidence, scientists figure these ancient trees grew to be about 8 meters tall. That is over 26 feet. Just try to picture that for a second. A world that, up until then, had been mostly barren rock, suddenly covered in a forest on that scale. Mind-blowing.
So as we start to pull all these different clues together, this really clear picture starts to emerge. Fossils aren't just, old dead things. They're basically time machines.
Think about the journey we've just been on. We went from microscopic little organisms that literally changed our entire planet's atmosphere to giant sea scorpions ruling the oceans, and then to the rise of the first massive forests on land. Every single fossil is like a page in a book, and when you put them all together, they tell the absolutely epic story of life on Earth.
It really makes you wonder, doesn't it? Every single place on this planet has its own deep, ancient history recorded in stone. So the final thought I want to leave you with is this. What incredible story is hidden in the rocks, right beneath your own feet?